The global production of electric vehicles is expected to reach 30 million units by 2030. Fast charging and high mileage are essential features for future electric vehicles. Highly conductive materials such as copper and aluminum are widely used because they can meet the demand. Traditional battery modules use resistive welding to connect the battery cells to the conductive copper plates, which is an energy-consuming and time-consuming process. Although 3,000 watts far-infrared laser sources are used to replace resistance welding now, but they still face quality problems like high energy consumption and spatter. The absorption rate of blue light on copper and aluminum is 3 to 15 times higher than that of far-infrared light. Not only does it cause less splashing, but also consumes only 1/3 of the power of far-infrared lasers. The Industrial Technology Research Institute has developed a high-brightness blue light laser in battery electrode manufacturing process, which reduces power consumption by more than 50% and improves welding quality. This technology also can be applied to electric motors, charging piles, etc., and is a powerful tool for the electric vehicle industry.